Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2185, indicates a high voltage condition in the ECT sensor 2 circuit of the Honda Civic models from 2011 to 2015. The engine coolant temperature, ECT sensor, plays a significant role in monitoring the engine's temperature, which is critical for both performance and emissions control. Specifically, ECT Sensor 2 is utilized for more refined temperature calculations and operates in conjunction with the Engine Control Module, ECM. Proper function of the ECT sensor facilitates optimal fuel injection and ignition timing. Thus, recognizing the implications of a DTC P2185 is critical for maintaining the overall health of the vehicle's engine. Addressing this error involves a systematic approach, encompassing verification of symptoms and checking the condition of the sensor and associated wiring. The ECT Sensor 2 is responsible for monitoring the engine's coolant temperature, which is crucial for maintaining optimal engine operation. It is typically located near the engine block, allowing it to accurately gauge the temperature of the coolant as it circulates. Proper functioning of this sensor ensures that the Engine Control Module, ECM, can make essential adjustments to fuel injection and ignition timing based on the current temperature readings. If the ECT Sensor 2 reports inaccuracies, such as temperatures that are too low or inappropriately high voltage levels, it can lead to performance issues and increased emissions. Understanding this sensor's function is key to diagnosing DTC P2185 effectively. When troubleshooting DTC P2185, several potential causes must be considered. A faulty ECT Sensor 2 is the most straightforward culprit, as it may output erroneous readings that trigger the high voltage condition. Additionally, damaged wiring or connectors connected to the sensor can lead to similar faults, often due to wear or environmental exposure. ECM software issues can also contribute to miscommunication between components, potentially misreading data from the ECT sensor. Lastly, intermittent electrical issues, such as loose connections, can cause sporadic faults, complicating diagnostics and repair. Each of these causes must be investigated to isolate the problem effectively. The symptoms associated with DTC P2185 can significantly affect a vehicle's performance and should not be overlooked. One of the most immediate indicators is the illumination of the check engine light, CEL, which serves as a warning to the driver. Alongside the CEL, drivers might experience poor engine performance, which can manifest as stalling, hesitation, or rough idling. Increased emissions may occur due to improper fuel-air mixture adjustments, leading to environmental concerns and potential inspection failures. Additionally, drivers might notice abnormal fuel consumption, as the engine may work harder to compensate for poor temperature readings. Recognizing these symptoms can guide timely repairs. In the first troubleshooting step for P2185, begin by turning the ignition switch to the on position without starting the engine. This action allows the system to activate and provide relevant data. Utilize a Honda Diagnostics system, HDS, to check the ECT Sensor 2 data in the data list. If the reading indicates temperatures around -40 degrees Fahrenheit, -40 degrees Celsius, or a voltage of 4.92 V or more, this confirms that the original failure condition has been duplicated. In this case, you would proceed to the next troubleshooting step. However, if the reading is normal, it signifies an intermittent failure, indicating the system might be functioning correctly at that moment. Thus, checking for poor connections or loose terminals at the ECT Sensor 2 and the ECM would be advised. For the second step of troubleshooting DTC P2185, turn the ignition switch to lock 0 to ensure safety while working on the electrical components. Next, disconnect the ECT sensor 2 connector, which contains 2 pins, the black wire, number 1, and the green wire, number 2. Using a jumper wire, connect these 2 terminals, A and B, to create a direct circuit. After setting this up, turn the ignition switch back to on. The intention here is to create a controlled test environment while checking the ECT sensor data once again through the HDS. If you find that the readings still indicate negative 40 degrees Fahrenheit or 4.92 volts or higher, this implies a problem in the sensor itself and warrants replacement. If not, troubleshooting continues to further isolate the issue. In the third troubleshooting step for DTC P2185, revert to safety by turning the ignition switch back to lock 0. Remove the jumper wire previously connected to the ECT sensor 2 connector to restore the normal connection state. After doing this, turn the ignition switch to on 2 again and prepare to measure voltage. Use a multimeter to check the voltage between the designated test points. Specifically test point 1 at the ECT sensor 2 connector, number 2, green wire, and test point 2 at a solid body ground. The goal is to determine if the voltage is approximately 5.0 V under these conditions. This measurement will indicate whether the TW2 sensor line is functioning correctly or if further investigation is necessary. The fourth step in addressing DTC P2185 involves first ensuring safety by turning the ignition switch to lock 0. Utilizing your diagnostic tools, jump the SCS line with the HDS to bypass the system temporarily. Following this, disconnect the ECM connector A, which typically contains 49 pins. Now, you will need to check for continuity between 2 specific points. Test point 1 at the ECM connector A, number 10, black wire, and test point 2 at the ECT sensor 2 connector, number 1, black wire. This test aims to ascertain whether the SG6 wire is intact and without breaks. If continuity is confirmed, the SG6 wire is functioning properly, and the next steps would involve checking for ECM software versions or trying a known good ECM. If continuity does not exist, further investigation of the wire for damage or disconnection is necessary. The fifth and final troubleshooting step for DTC P2185 mirrors some procedures from previous steps. Begin by turning the ignition switch to lock 0 for safety. Again, use the HDS to jump the SCS line. Disconnect the ECM connector A, 49P, to prepare for the continuity test. Now, you will measure continuity between test point 1 at ECM connector A, number 44, green wire, and test point 2 at ECT sensor 2, connector number 2, green wire. It's essential to confirm that the TW2 sensor wire remains intact. If continuity is present, this suggests the wire is functioning correctly. Further steps would involve ensuring the ECM is up to date. If no continuity is found, it will be necessary to repair the connection in the TW2 sensor wire. After addressing the faults associated with DTC P2185, it is crucial to conduct a final repair verification. Begin by turning the ignition switch to lock 0. Ensure that all connectors related to the ECT sensor 2 and the ECM have been securely reconnected. Once everything is in place, turn the ignition back to on 2 and reset the ECM using the HDS. This step is essential to clear any fault codes and allow the ECM to recalibrate its parameters following repair. Additionally, perform the ECM idle learn procedure to allow it to adapt to the engine's current operating conditions. After completing these steps, check for any pending or confirmed DTCs. This validation ensures that the repair was successful and the issue has been resolved. Preventive maintenance is vital in mitigating issues like DTC P2185 from arising in the future. Regularly inspecting the integrity of electrical connectors associated with the ECT sensor and ECM can help detect any wear or potential corrosion before it leads to system failures. Additionally, monitoring coolant temperature readings during routine diagnostics allows for early detection of deviations that may indicate sensor failure. Keeping the ECM software updated is crucial for ensuring compatibility and optimal performance of the sensor, as manufacturers often release updates that enhance both functionality and reliability. Implementing these maintenance measures aids in maintaining the health of the vehicle and preventing costly repairs down the line. In conclusion, DTC P2185 represents a significant fault that indicates high voltage in the ECT sensor 2 circuit. This diagnostic code highlights the importance of the ECT sensor's role in ensuring the engine operates efficiently and effectively. A methodical approach, starting from verifying symptoms to detailed wiring checks, is crucial in identifying the root cause of the issue. Understanding the interconnectedness of the ECT sensor, ECM, and the associated wiring helps enhance diagnostic accuracy. By following the outlined troubleshooting protocol and implementing regular preventive maintenance, vehicle owners can safeguard against future failures related to this DTC. Ultimately, proper diagnosis and timely repairs contribute to maintaining vehicle reliability and performance. Please like and subscribe to the channel. See you next time.